your destiny. Good morning, student. Good morning to your destiny. Now, like I've been showing you about the drawing. So this is the cam. This is the cam assembly, and this is the cam shaft, and this is the gear. This cam is driven by the engine like this. So as it is moving, you can see the follower here from this place. You can see the follower is also moving. So when you are told to draw the cam profile, you're simply going to draw how the cam is rotating the follower like this, because the follower has to be on this part. So when it is like this, the follower is lifted up. When it is like this, the follower is on dwell. When it is like this, the follower is still on dwell. When it is like this, the follower now has a return stroke. So we have the out stroke on the right, we have the dwell, then we have the return stroke, then we have the dwell, and then we have the out stroke. Please subscribe to my YouTube channel and I will show you more about this. Good morning, students. Emmanuel, God is with us. God has indeed blessed us. God has given us everything. All knowledge belongs to God. Give God glory, and God will always do something good for you. So in my previous videos, I've shown you how to draw the cam displacement under simple harmonic motion, cam displacement diagram under uniform acceleration and retardation motion. Now I want to show you how to draw a cam displacement diagram under uniform and velocity motion. Remember, I've told you from this past paper here that you cannot draw this cam profile without cam displacement graph. You must always draw using a cam displacement graph so that you can draw the cam profile. And this section of the question, this part of the question is part B of the question. It is always carrying good number of marks, which is 14 marks. In KNEC, you only need 40 marks so that you can pass your exam. And you are having a question that is 20 marks. Very simple. You have been told to sketch the following types of cam follower. We have sketched it. If you have not watch my previous video, I've shown you how to sketch knife, flat-faced and roller followers. Now we are doing the second part of the question, but I've decided to first take you step by step, not to quickly rush you, but to take you step by step so that you can get these 20 marks. Then also do the gear question, get your 20 marks. That is already 40 marks. Do the assembly drawings and do other parts of the question. Get your marks, pass on the knowledge to other people that are desperately in need of it. Remember, we have brothers and sisters in Wajir, in Marsabit, in hardship area, in Kilifi, in Webuye, in Makueni, in Makindu, and they are passing through hard times. They don't have this knowledge. They don't have the necessary skills and teachers and competent teachers to teach them. But we thank God for this grace of online tutorial videos and the internet. God has given us this grace so that we may use it. So please subscribe to my YouTube channel and you will watch some of these amazing videos that will help you not to waste your school fees, but to actually utilize your school fees for a better Kenya, for a better nation. Don't be the problem, be part of the solution. Don't criticize, don't complain all the time. Be part of the problem. With the little that you have, of the much that you have, you can always solve and give a great nation such as this, our motherland that we love. So, uniform velocity. Under uniform velocity, I will now show you quickly how to construct. Since the follower moves with uniform velocity during rise and return stroke, therefore the slope of the displacement curve must be constant. In other words, A, B, and CD must be straight lines. A little consideration will all show you that the follower remains at rest during part of the cam rotation. The period at which the cam remains at rest is known as dwell period. So we have talked of outstroke, you have talked of dwell, and you have also talked of return stroke, and also talked of dwell. The very first thing that you're given here, we will use just an example. I've told you I'm just using examples, simple examples. First, let us look at the stroke. The stroke, we are told it is, maybe let us use it as 6 centimeters like I've used it in the previous videos. Let our stroke be 6 centimeters. After you've been able to establish that the stroke is 6 centimeters, the next point that you use is that this, let us say this is the x-axis. This is the x-axis. The y-axis, it is the angular displacement. It is always the angular displacement. It means that the cam is rotating at 360 degrees. But now we have to convert this angular displacement into actually angular displacement, or a straight line, like into a linear displacement, which is always a straight line. And here we must use a scale. And I've always told you, I use a simple scale. I say that 360 degrees is equals to 18 centimeters. I use 18 centimeters because it is simple to divide your outstroke and return stroke into suitable numbers. Let's say 6, without having many decimal points, which will be difficult when you're dividing them. So I use this scale, that 360 degrees is equals to 18 centimeters. Remember, in the question you'll be given the value of the outstroke, which is always in degrees. You'll also be given the value of the dwell, which is always equals in degrees. You will be given the value of the return stroke, which is always equals to degrees. So what am I supposed to do? I'm supposed to convert these degrees into centimeters so that I can actually display them here using a graph like this. That is why we are using this scale. That 360 degrees is equals to 18 centimeters. In your question, you'll be given outstroke in degrees. You'll be given a return stroke in degrees. In some instances, you'll be given in seconds and minutes. It is you now to think and to convert all these measurements now and use them in centimeters. Now, in this question, let us assume that we have our stroke. Our stroke is the vertical height from here to here as 6 centimeters. And also, let us assume that our angular displacement, the 360 displacement is 18 centimeters. So you draw 18 centimeters, measure on your ruler like that, 18 centimeters. Then stand here on top again, ascend again here. At this point, again, draw your 18 centimeters. Sorry. Let me correct this so that it can appear very well. Let me draw it. Let me measure it as 18 centimeters. 18 centimeters from my ruler like this. So this will be 18 centimeters, just like that. Then after you've obtained such a point, again join and link your 6 centimeters like this. You can see here there's a little error. Let me correct it. Now I love being perfect. KNEC question demand a lot of accuracy and a lot of speed, but in this case God has helped us. It is not a question that we are doing. It is not an exam that you are doing. We are learning. So, but in your exam, it is required of you that you will have done a lot of practice. You must have done a lot of practice so that you can give very accurate measurements when performing all these calculations and doing this good work that you're doing. Remember, school fees is a lot of money, so make sure you learn, and you learn properly. So after you've done all these things and after you've acquired such things, in uniform velocity motion displacement diagram, it is just like the same thing. Look for the value of the outstroke, all of the outstroke, all of the rise. Let us say the outstroke is 90 degrees. So we using our scale, we say 360 degrees is equals to 18 centimeters. What about 90 degrees? So you say 90 times 18 divided by 360, it will be 4.5 centimeters. So actually now we can draw 4.5 centimeters on our graph like this. So 4.5 centimeters at this point, 4.5 centimeters again from this point, it will be at that point. So from this point, again you draw a straight line like that. Draw a vertical line like that. Then let us say from here now, from the outstroke or the rise, we had again, we have another that we call a dwell. The dwell is 30 degrees. Let us say the dwell is 30 degrees. So you say 30 times 18 divided by 360, it will be 1.5 centimeters. So again, from this point again, you draw 1.5 centimeters again at that point. Then again on top here, again look for 1.5 centimeters again from that point. Yes, like that. So you can now draw a straight line that is now indicates our dwell in our displacement diagram. Then the next part that you use is that you've been told again from this point to any other point. From this point to any other point, you will have to use you'll have a return stroke. A return stroke that is coming down. Let us say the return stroke is 60 degrees. So you say 60 times 18 divided by 360. It will be 3 centimeters. Again, standing from this point here, draw 3 centimeters like that. And then standing again on this point, again draw 3 centimeters like that. So from here, you can now draw like that. So this is our return stroke. This has become a return stroke. Then again here we will label it. That is our dwell. So you come here again using your ruler now. Using your ruler, label very well like that. You use a lot of good work like that so that the examiner can know that this man, or the marker can know that this man was actually he knew what he was doing, or this girl is actually bright, which is a good thing, and we give God the glory. So this was 90 degrees, this was 30 degrees, this was 60 degrees, and this will be 180 degrees, so that to complete 360 degrees. So so here this was the out stroke or rise. In some question will be given rise. This will be dwell. This will be the return stroke, or in some instances it can be called as fall, can be given in a question. Then this is the dwell. Then that is the dwell. After you have interpreted your question like that, we are now almost doing properly. Again, you divide the distance, the outstroke distance from here to here, divide it into equal numbers. What was our number? It was 4.5 divided by 6. Always use, now I use 6 even numbers. You're told even numbers, so you can use 6, 4, 3, 6, 4, 8, 6, 4, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, or 30. You can always divide it into equal parts that you want. But in exam, you're always given a small size of a drawing paper. So you must always use the smallest number in dividing, and that is 6. 6 can be the smallest. So divide this, so it will be 0.75. So you measure 0.5. Again, standing from this point, 0.575. Again, 0.75. Again at this point, 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 and 0.75 again at that point. Then from this particular point, draw construction line. There is so much straight lines like that. Using your construction lines like that, you draw a very nice competition like that. So having done that, we have now established this point. So having done that, you again divide the return stroke. The return stroke here, our return stroke was 3 centimeters. So 3 divided by 6, it will be 0.5. So 0.5 divided 6 times. I always use 6. You can always use 6. It is the best option. So 0.5, 0.5, 0.5, 0.5, 0.5, 6 times. So we have divided this 0.5 6 times. Again, stand here, draw vertical lines like that, draw another vertical line like that, draw vertical lines like that, draw vertical lines like that. As you can see very well, we have been able to establish all these things. Now, so what do we do again? From this point, what do we do? So from this point, what do we do? We now want to draw uniform velocity. As you can see in our description up here, uniform velocity, there is no other formula. There is no looking for where things are intersecting, lines are intersecting. Just draw a straight line like this. It is uniform velocity. This will be our dwell. this becomes our dwell. Yeah, then this will become our fall. This is now our fall, like that. That is now what we call uniform velocity. So this is B, C, D, E, F, G, H, I, J, K, L, M, N. So where they intersect, where this straight line intersect, you mark like that, 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 mark it, put a mark, 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 put a mark like that. Now I have shown you how to draw, that is the graph now for uniform acceleration, the cam displacement for uniform. So here, this is always the dwell. You can always maybe label here. This is a stroke, and our stroke was 6 centimeters. The stroke was 6 centimeters, which can always be given either in centimeters or in millimeters. So this will be 60 millimeters. Even in my previous videos, I have labeled. So the outstroke, the dwell, the return stroke, then the dwell. Use what I am saying, use the formulas that I'm saying, and you will see how simple this is. In my next video now, I want to do some calculations for you, to do some examples, some actual practical examples for you, so that I can show you why we have to apply these displacement diagrams under uniform velocity, under simple harmonic acceleration, simple harmonic motion, and under uniform acceleration and retardation motion, to apply in an actual question. But usually in KNEC past paper question, in KNEC, they will always give you a combine. They can give you a combine. You combine you can see here, this is a combination of simple harmonic motion, because we are told the rise, it is rising in simple harmonic motion between 60 degrees and 180 degrees. I have told you they always give you in degrees, you see, and you are given the stroke. The stroke is 5 millimeters or 0.5 centimeters. In that case, if you must convert it, you see their measurements, they give in millimeters. So your ruler has no millimeters. Your ruler is always labeled in centimeters like this. So you must always convert these millimeters into centimeters, and we all know how we do it. It is 10 millimeters. 10 millimeters is equals to 1 centimeter. So if you've been given is 15, what is 15 millimeters? You transpose the formula to 15 centimeters times 15 millimeters times 1 centimeter times 1 centimeter over 10 millimeters. So millimeter and millimeter it will be 1.5 centimeters. So it is 1.5 centimeters. You have that in your ruler. It will be 1.5 millimeters. Or if you have a ruler that has millimeters, you can use it. You don't have to convert it. So you can see we are supposed to draw the displacement graph so that we can draw the cam profile. So we are told there is a rise or the outstroke. I've told you it is a rise or outstroke of 5 millimeters and 6 with simple harmonic, and we are being given the dwell. It is always given in degrees. It is up to you to convert it into centimeters so you can draw. You have been given the dwell, and also we have been given a fall, the fall of the remainder with uniform acceleration. So this is a combination of simple harmonic and uniform acceleration and retardation motion. So for you to do this question, you must have a complete good knowledge of uniform velocity or simple retardation, of uniform acceleration and retardation motion, and you must also have a complete and sound knowledge on simple harmonic so that you can combine them and get your 20 marks simple questions. Please subscribe to my YouTube channel and watch more of this. God bless you.